this will be our review for the two kinds of indirect proofs that we talked about in class. Indirect proofs differ from direct proofs in that they involve the use of assumptions. And how the two indirect proofs that we've talked about, conditional proof and reductio ad absurdum, differ is what assumption we make and what we're trying to do with that assumption, or should I say, under that assumption. So we use a conditional proof when the conclusion of the argument is itself a conditional. So there we go, there's the conclusion of this argument, and it is the conditional H arrow J. And the assumption that we make is that the antecedent of that conditional is true. We assume H. And what we're trying to do under that assumption is show that we can derive the consequent, J. So here's how we'll set it up. We make this line to show that we are making an assumption. That's what the box indicates. Assume. H is an assumption, and from H and this premise can we derive J. So that's where we're going to start. Okay, so under H, what can we do? We're trying to get to J. And I think we can actually do this pretty quickly. That's from 2, addition. So all I've done here is I have formed a disjunction, tilde G, VH, through the rule of addition. Once we've got that, through our rule of material implication, we can get G arrow H, and from G arrow H, we can get J through modus ponens of 1 and 4. We have now arrived at what we were trying to get, the consequent. Our assumption now is over because what we were trying to do under our assumption was to show that we could get to the consequent J under the assumption that H is true. And we've done that, so our proof is over. And what have we shown is true? That H arrow J follows from 2 through 5 conditional proof. Let's do a couple more just so we know we have the basic idea. So here we have, again, let's start with this argument over here, where we have E arrow K as our conclusion. To start, we're going to, remember, assume the truth of the antecedent of that conditional, and just that, assume. And under that assumption, we want to arrive at K. Put that box in there, showing that we're making an assumption. Okay, well now, what can we do? Under the assumption of E, well, looks like one thing that we might want to try to do is, let's try this. Oops. EVL from 2, addition. Again, just like we did before, we just put together a disjunction. And just keep this assumption going. And then what we're going to do, let's do double negation on that, because what this is the denial of this. And what does that allow us to do? It allows us to derive K from 1 and 4 disjunctive syllogism. Now that we've arrived at K, we close out our assumption. I'm sorry, that line went a little too long. And what have we shown? E arrow K from 2 through 5 conditional proof. All right, let's try this one. And again, what we're trying to do is, on the assumption that W is true, show that X follows. So let's start with our assumption. Our assumption is W. Let's just assume that. But it doesn't look straight away like we can do much just with W. So we're going to have to do some work. One thing that I see here is this is a good candidate for distribution. So I'm going to try that tilde x v o dot tilde x v w from one distribution. And then I have w here. So one thing I could try is simplification of this tilde x v o, and there's a reason why I took that one. And that's from 4 simplification. We had this conjunction and we just took this part of it. Then we're going to, we do not want to keep that tilde. Here's what we're going to do. We're going to take that and turn it into this conditional. And once we've done that, we get w arrow x. And that is from 6.1 modus ponens. Now, you might think you're done because we've arrived, as you see, at the conclusion, but we're not done yet because we haven't stopped assuming the truth of w. We're still inside this assumption, so our proof can't be done. We have a couple more lines to go. If w arrow x is correct and we have w here, that was our initial assumption, we may validly infer x. This is what we're after to close out our assumption. And so we can say from 3.7 modus ponens, we get x, and then line 9 is w arrow x, and that is 3 through 8 conditional proof. All right, let's talk about our other kind of proof, which is the reductio ad absurdum. This is also an indirect proof in that we're going to make the use of an assumption, but we don't make the same assumption. The assumption for reductio ad absurdum is the opposite truth value of the conclusion. So that's what we're going to assume. So here it's tilde c. We're going to end up assuming c, the opposite truth value. And what we're trying to do under this assumption is show that it leads to a contradiction. And you can read the book about the theory of this, but I just want to go through the steps and the procedures and what we're trying to do. For RAA, it's generally always good to make the assumption your first move. Sometimes when you work with conditional proof, you don't necessarily need it to be the first assumption, but here for RAA, it usually makes the most sense. And so we're going to assume the truth of C, which is the opposite truth value of the conclusion, tilde C, and we're going to see if we can arrive at a contradiction. Any contradiction. Doesn't have to be the same contradiction. It could be any contradiction. So let's assume the truth of C. Now from C, going up to this conditional, I can see that I can get tilde B from 1.5 modus ponens. And once I have tilde B going up to 2, I can get tilde D from 2.6 modus ponens. Let's see, now that I have tilde D, I can look at this disjunction and say that I can validly infer from this disjunction the truth of E through 3.7 disjunctive syllogism. Gonna move over here real quick, take away that. I'm gonna need that space. Let's do line 9. So I've got E, and from E, this assumption continues, going here, I can get D from 4.8 modus ponens. Again, I'm trying to arrive at a contradiction, and here's a contradiction, and here's what's important. The contradiction should always be some statement plus its opposite. What you want is that conjunction of a statement. In this case, we're going to go D and tilde D. And that's from 9.7 conjunction. We're putting together that conjunction. Why? Because this is a contradiction, and in the formal sense, in which on every possible truth value assignment of D, this statement is false. It cannot possibly be true. And so what have we shown? We've shown that the opposite truth value of the conclusion leads to a contradiction. And the theory here is that anything that leads to a contradiction must itself be false. And so if C leads to a contradiction, then C must be true. And we prove that 5 through 10 are A. And let's just do a couple more to make sure that we've got the system down. So again, we're going to assume the opposite truth value of the conclusion. In this case, that's Z. From Z, we can conclude X, V, Y. Sorry, I don't need that. From 1, 5 modus ponens. And once I have X, V, Y, what I see is that I have those two right there. And so what this gives me is tilde W, V, tilde W. From 6 to 3, constructive dilemma. Because this is a V, we can't use simplification, but we can use another rule. We can use redundancy. And that allows us to take this tilde W off, tilde W, V, tilde W. Now that we've got tilde W, we can take this, look up here to there, and get tilde Z from 4, 8 modus ponens. Oops, not and done yet. And now we can put together our contradiction, because here's what we have. We have tilde Z, we have Z, Z dot tilde Z, and that is from 5, 9 conjunction. And what has that shown? Well, it's shown that Z can't be true. And if Z can't be true, then tilde Z must be. So we have proven tilde Z from 5 through 10 are A. One more? Sure, why not? I want to do this one because this might throw some of you off. The opposite truth value of this statement is not this, though some of you might be tempted in that direction given all that we've done before. No. In fact, the opposite truth value is the negation of the whole thing. And so that's what we are going to assume. All right. And then under that assumption, what kind of contradiction can we get? Whenever I see a V that's being negated like this, I always want to try De Morgan's on that. And so let's see what we end up with that. So that was 4 De Morgan's. And then let's take that through simplification. We can take off one of the conjuncts. Let's do that through double negation. Now once we've got... No, wait. Did I want W? Oh yes, now that we've got W, we can come up here and get X, V, G from 1, 7 modus ponens. And then we can get tilde G from 2, 3 modus tollens. And then that will give us here X from 8, 9 disjunctive syllogism. All right, let's move up here for line 11 still under the assumption. So line 11, I see something useful here. I've gotten to x. I also have a tilde x over here on this dot. And so I can simplify that off. So that's 5 simplification. And now I can put together my contradiction. X dot tilde x, and that is from 10, 11 conjunction. And now we can close out the proof. 13 is on the assumption that this is true. We've derived a contradiction. So in fact, this must be true. We have proven tilde w vx from 4 through 12 are AA.